University, you're very, very much welcome. We are very glad to have you on this call. And then, as you all can testify, today is going to be another awesome and great section to learn how to master the use of Azure for machine learning. We're going to make machine learning model building very, very easy for us. And I'm sure that since Monday that we started learning, you can do something now, and then you can even drop your experience, what you've been learning since Monday, your experience, you can just drop it in the chat for others to learn from. So there's an important information that I want to share with everyone. I would like you to confirm that you can you can see my screen in just a minute, few minutes. Okay. Okay, so there is an event on NVIDIA Trustworthy AI that we like every one of us to join. It's happening today, and then we didn't want to bore you. We don't want to bore you with it. That is why we have not been sharing this with you. But if anyone will be available, it will be happening 2:30. It is not enough to build solutions. It is better to build a responsible solution, and that is what this session will focus on. I want you to confirm that you can see my screen now. So that is the flyer for the Trustworthy AI, and then my colleague Chidima has dropped the link to register. Also, Chidima will be dropping this flyer and the links to join in a Telegram group, so that if you're interested, because it'll be coming up 1 or 30 minutes after today's section, so that if you're available for it, you can just join, so that you won't just build solutions, but you will build transparent and unbiased AI solutions. So without taking much of our time, don't forget that attendance will be dropped 1 hour. Attendance link will be dropped 1 hour after we have started the class. Okay, so don't fill the chat room with attendance. Okay, let's learn, and after 1 hour to be dropped, and after that to be dropped in intervals of maybe 15 minutes. Okay, so that we can all register our name in the attendance form. Okay, so without taking much of our time, let me just introduce the tutor, none other person than Emmanuel. So Emmanuel, good morning, and then over to you.
Good morning, Tejola, and thank you for the introduction. I'm very glad to be here to listen our lesson. And good morning to everyone too. I hope you guys are also excited as I am to learn more about machine learning with Azure. So let me share my screen. So we started on Monday with our machine learning with Azure, free AI classes in every city. So we started on Monday with designing a machine learning solution. So we went over what it takes to build run a machine learning workload on the Azure platform, right? So we were able to give a brief overview of everything that you need, every resources. For instance, the first thing you need first is to get an Azure subscription. So please, if you are still having an issue, yes, now please say it in the chat so that they can my colleague can attend to you, because you can't do anything on the platform without getting an Azure subscription, either using a student's account or registering for the $200 free by using a debit card. So I think they recharge $1 or $2 just once, and you're able to use $200 free Azure credit to run as much and learn as much as you want on the platform. So on day 2, we did Azure machine learning workspace. So we went to the workspace, right? So we've been talking about this Azure platform. So we went there and we were able to have a look at all the resources available there. So we're able to be familiarized with all the functionalities. If you want to run a data, if you want to put your data, so we're able to learn how to put our data into the workspace. Yeah, okay, first thing first, you need to create an Azure subscription, right? Then you create a resource group that will encompass all what you'll be doing for that particular machine learning workload, right? So, and then you start, then you start your machine learning workspace. So you can interact with the Azure platform to develop and run your machine learning. We say that there are 3 ways. So we can do it through either Python SDK, the Azure CLI, and the Machine Learning Studio, which is the one on ml.azure.com. So we're able to be able to learn some things, learn about complete resources and so. So please, you can check back on the videos to learn more about them. So now today, now we are now going further to learn how to experiment and optimize our machine learning model training. So, just like just like I said on Monday, the aim of this course is for you to be able to take and pass the DP100 designing and implementing a data science solution on Azure certification. So please make sure you practice everything we learn in class. After each class, make sure you go through the my curriculum yourself. You practice everything, you go through it, you study, you take down some notes so you can be able to apply them and then get the Azure subscription so you can practice online, create create a workspace, right? Create a workspace by yourself, deploy it, try the other method, try any try the options available for you to run your to interact with the Azure and get familiar with all the offerings on the platform. So yeah, so on today on I'll now to explore experimentation. Today is experimentation and optimization of a machine learning model on Azure. I don't know why I got that title wrong. Yes, it's experimentation and optimization on the Azure. Okay, so what we're going to be learning today is in 6 modules. So the first thing is we are going to learn how to use the AutoML. So auto ML means automated machine learning. So it is so we are going to be learning, we are going to go there further on that later. So after learning that, we are going to go to how to track your models, right? What does it mean that you to track? So you'll be learning that how to track it when you're working on Jupyter notebooks on the Azure platform using MLflow. So then you then later learn how to optimize our model training, like the process. How can we optimize it so that everything is automated, right? So you learn how to turn your training scripts that you did in your Jupyter notebooks, you turn into a command job. So you also learn how to use machine learning flow to track the jobs, and then you learn how to tune parameters to get the optimum machine learning model with the best performance for your workload, for your task. So then you learn about pipelines, that what does it entails to use pipelines. Okay. So now, for the first module, so why do we need to use auto? Well, what is the need? Sorry, what is the need for auto ML, right? Auto ML is automated machine learning. So so let's look at this case scenario now. So you have a sample, a problem, right? That maybe because a client comes to you that they want to they want to be able to know the price, the worth of a car, right? Using your model. So then now you embark on this machine learning journey. So what you are going to do is that you get data. They are going to either supply you with the data or you acquire it yourself through the necessary means. So now, so looking at the data, you can see that the data here has all these features. These are the features in the data, which corresponds to the column in your either your CSV. So these are the features. It has mileage, condition, car brand, year of make, regulations. So you need to know that, okay, which one is the features? Which one is the, if your task is a classification task, so you need to know which one will be the maybe the target variable, that the one that will be the output, right? So you take it out. So looking at all this scenario, okay, so which are the features, which is the best one to use? So you start, okay, you just, okay, let me start. Yes, maybe you decide to start with mileage, car brand, and years of make. So you take all these features, then you now start going to density, which is now decide on the algorithm to use. That will be, you will know what you are going to use when you know that, okay, is the task I'm running, is it a classification? So since in this case scenario now, they want to know how much the car is worth, so which is a numerical data. So automatically it is a regression problem, right? So you look at the algorithms available, okay, which one can work for which of these algorithms will fit the regression problem that I want. So you now pick, you start, there are many regression algorithms available. So you can pick the one that you start experimenting with, the one that give you best performance. So after doing that, you now get parameters. So you now look at, okay, which parameters are the ones that will give you the best models, and looking at the performance now, you see it has 30% accuracy. So then you start going back again, start changing, use some parameters again. So this can get, typically is very time consuming. Okay, so so this is where automated ML comes in. So it's the side of processing the data. So it automatically does this for you, it will clean it for you. Yeah, instead of you manually searching for missing data, or anything wrong with the data, or some bad data, or data that are not properly formatted. So it does it for you automatically. Then it can also help you to feature in the do feature engineering, where you can manufacture features that you believe, maybe the data you have, maybe some of the features, you can divide it into two. Okay, so you divide it into two to train your model. So this also does it for you automatically. It knows this already, and it selects the best algorithm for you. So it does all these things all at once. Then it performs the parameter tuning. Then it now gives you the recommends the best model for you. Then and also explain the model, explain what it does, and how the outcome comes to be. So you'll be able to see, okay, you're able to, okay, so this is going to speed up your working process. So I think let's start working with the curriculum now. So let me share my page. Let me share my browser. So now this is our curriculum for the whole program. So now we are on day 3 of the machine learning with Azure. So let's start with experiment, how to conduct experiment on the Azure machine learning, right? So like I said previously, so how can you, okay, let's say the task you are dealing with is a classification problem, right? So how can you find it automatically using automated email? So you start from, let me go here. Okay, so we can see that this is how it works. Okay, so this is how it works. So you can run all these experiments using the Azure Machine Learning Studio, using the Azure CLI or the Python SDK. These are the one of the ways you can run this auto ML. So so now for you to so now in our day 2, we talk about how to put data, right? That you can put it in either as a file folder or in a table. That is when you that's after you've gotten the data, right? So you want to put it in, make it available on the Azure platform, so your model can be able to access it and use it for training. So after you collected your data, right, and you created a data asset, which we went through yesterday, then to use it, you need to create ML table. Because L2ML doesn't support URI or URI folder. You must use ML table for it. So you do this. This is one of the ways you can do this using the Python SDK. So you write this code, you import all these packages from these libraries, and so then you apply it like this, then you say, then you use this code. This you want to do it using a Python SDK. So now automatically, AutoML applies scaling and normalization. So I believe you are all not know this when it comes to the machine learning process, right? And in the data aspect, where you do data processing, you have to scale your data because the machine learning perform best on data that are scaled and normalized. Okay, so you need to scale your data. So this automatically, you don't need to do anything. It automatically applies, although you can turn this off. Okay, so automatically it scales and normalizes your data. So you don't need to do that. So also it also gives you other options, right? So it gives you this option of missing value. Then you can give it what to do with the missing value. What should you do with the missing value? Should you eliminate the row or you should input a particular values there for you automatically? Then it does this thing for you, categorical encoding. So if you're having in your data and you have what we call categorical data, or we have what we call numerical data. So it does this thing for you, so it encodes them for you. And it also does so normally when we train our data, most of our data usually comes with especially when we deal with companies when we deal with data that comes from about customers and companies and profiles database, it usually comes with what we call ID. So this thing automatically removes it for you. So that's what we call high additional feature. It drops it for you because it's not a feature. So this particular column of data is useless to train our model. So it drops it automatically for you. And I can also do other feature engineering that you want to it. So by default, it does all this featureization for you and you can disable it if you want. So now these are depending on the task you specified, okay, the algorithm we choose for a list from so depending it's going to ask is the class is it a computer vision task, is it a classification task, is it a education task. So in the case that you choose that your task is a classification task, right, so it's going to give you the list of classification algorithms. So all these that you are seeing here, logistics, decision tree, random forest, all these are available. So it's going to test all of them. So by default, it's going to randomly select from all these of algorithm for you, right? So this is how you can implement it. How you can configure the experiments using the Python SDK format. So now you can specify primary metric. That means which metric do you want it to use? Maybe since you are dealing with a classification task, your metrics include AUC, that's the area under curves, or using precision, recall, and so on. So you can design on the so you can also set limits because since this is going to achieve too many algorithms, so you need to also set limits for it. You can give a timer that okay, after a number of minutes, it shouldn't complete, it should stop the process, right? So after a particular minute, so you shouldn't just keep running on forever because it can also waste time. So you need to give it amount of, so you use all these things to set limits that okay, maybe you want it to terminate early when what? Maybe when the score is improving after a short time, because the train can just keep on going and going and going. You cannot get a good performance immediately. So or it has getting the performance and it's still trying to see if it can get better. So you can give it an early termination, maximum trials, timeout. So you do all this using this. So these are how you do it in the SDK. So you can see that enable termination is a Boolean word. So this is how you do it in the Python SDK. So now then how do you submit the after doing the configuration, how do you submit this the AutoML job. Since you are using a partner SQL, so you submit it as a script, right? So that's what we call it job. So this is what you use. So job, you are going to be using this particular function, right? So you use the create.update function. This classification job, you can see this is what you created the classification job already. So you can say you set the limits for it, you create the classification job already. So then you now pass it here, then you now say that you should start to create this. So this is when you are using, for people who like using VS Code as well, a VS Code or using any ID of their choice. So when you use Python, this is how you start. So you submit this thing so that the platform will see it, and as well platform will see it, then it starts running the code, right? So you can also monitor your you can also monitor the process, right? The what it's doing. So this is how you monitor the code. So now, so how does it evaluate and compare models, right? Because I told that it's going to test many models. So you can see that. So this is a scenario. So where models have been trained, he used voting ensemble, stack ensemble, he used like JVM, XG boost. So he used all these models. So these are the I could say there's a you can see that this is give you the accuracy, right? So you can pick the one that you want. So you can access this by going to on the machine learning studio. So when after running your code in Python, you can go to the machine learning studio. So you go to the you click on the job, then you'll be able to see this model type on it. So then you see all these are the results of the learning, right? So you're able to pick, okay, so you can see that from this now you can see that the best model, the best at least according to AutoML, that give us the best accuracy is voting. Yeah, I think yes, it's voting ensemble. Okay, so now it also offers all these um we've already talked about this already. So mostly for classification tags, that's what we call imbalanced data sets, right? Yeah, these are where maybe there's more instance of false occurrence. When you're trying to classify something, there maybe it's binary classification, so they're usually false or true. So most of the time, the occurrence of true is usually very low, and the percentage should not be there's a ratio, right? That it shouldn't be low below. So this thing or take this for example, without you having to go and stressing yourself, analyzing all this, so it detect the class imbalance for you, and it does missing feature. It does the cognitive feature discussion. That is the IDs that are useless for training. So it drops them and it does all this. So these are the processing steps. So these are so now this the data guardrails that will be applying the processing step by also involve. They will show you either of these things like pass, done, or alerted. So you can use this to monitor your model as how it is working. So now when you are not done and you want to uh retrieve the model that is the best, just like how we saw here. So you can just come in here, select the model, comes this model type, you can see the accuracy, then okay, say okay, this is the best one. So then you use that model, then you save it and register it. Let me just say save for now. So you pick the model you want, then you can. So now you can also explore further by clicking on the explanation. So it's going to tell you how it come about this. Like, okay, you okay, you gave you this passage. Okay, you are still curious, or rather you are skeptical. Okay, no, this can't be true. How come this accuracy is so high? So you want to look at how it got. Then you can read the explanation. Then it's going to show you how it's arrived at that particular accuracy, so that you can be able to make a better decision. Okay, it is not giving you it's not giving you a false results. So now, so after you are through with how to use this overview on how to use the AutoML, right? And don't forget that AutoML doesn't work with URI or UR Pro, that it works with only ML table. So you have to make sure that your data set has a defined ML table file which has a schema. So now let's go on to how to track model. The model that when you are training using the Jupyter notebook, how to track it. The only way you can the way you can do that in Azure platform is by using what we call ML flow, right? So then let's start. So what does tracking means? So track means that for you to maybe you just you want to be monitoring your data, like you train a model. Yeah, you want to be having multiple versions of it, like okay, version one, have a particular percent, maybe now training again, and you're not getting poor results. How do you get back to the version one? When the version 10 or the other version, newer versions are giving poor results, then this helps you to do it. And it also gives you a way to be logging your work, like logging your results, right? So tracking ML Flow is the library that offers these features for you on the Azure platform. So it can log everything about the model for the parameters. You can log everything about the metrics, the artifacts. So so we are going to be knowing about what does all this means in later on. So now, so let's say you are working with Azure machine learning, right? And you're using Jupyter Notebook, or you're working on your own local machine and you are using Jupyter Notebook or your local machine. So you need to make sure that this MS Flow is installed. ML Flow and Azure ML Flow, these two have to be installed. So you can use this command to check it, like, okay, is it installed? If it's not installed, then you run this command to install it for you, to install MS Flow for your local machine or on your Jupyter Notebook that you are using on the Azure platform. So then we now like so after this, so this is a way you can do it on on the machine learning studio. Let me go to the machine learning studio. Okay, so machine learning studio. So this is how the machine learning studio works. So on the workspace that you've created and accessing it on the machine learning studio, so you're able to go to the top right corner where it's okay. So when you have this installed already, then you can be able to get this the URI for it. You can see that it has the tracking URI. That means where it's going to be storing your wait, okay. So where it's going to be putting all the where it's going to be everything it does. So you need to be pointing it to your workspace. So you then need to use this format. You can see that the ML flow tracking URI. So now, so you can see this, it starts with Azure ML. So that means your data, when we talk about URI yesterday, we talked about that when the URI starts with Azure ML, it's that means you are using yeah, your data is you are using the data set on Azure. Right, so when you are using HTTPS, it means something. So this Azure ML means that you are using a particular URI for your to access your to track your to be tracking your model. This is where everything is stored in your workspace. So now let's continue after. So now we have a look at how to create an ML flow experiment, right? So using the SDK option. So you import the ML flow, then you run this command. So this is an example. So it's an example that you call this you call the self experiment, then you give it a name. Okay. So then you can start auto logging and custom logging. So these two uses different things. So you need to know these are the ways you can track your model, right? So this is how you do it in your Python code. Then you put ML flow. You can see that you use the autolog. So there are differences between using autolog and using custom flow. So when you use autolog, it automatically logs the by default. Where is it? So it automatically logs some parameters for you. Where is it? So it automatically logs these parameters, and these are the measures. These are how you can edit the parameters on the machine learning. Sorry, on the platform. This is the using the MS Studio. This is the one using the Python. So then, if I want to use a custom login, there are times that the auto logging maybe you want more custom or it's too maybe well, the first login, auto login is too much for you, or you want more information than what is offered by auto log, then that's when you can apply it to use of auto custom login. So this is how you do it. This is how you apply it in your work. So now then that's when you say you these are the functions that you now use to automatically log it. So the log param is used for logging parameters about your model. This one logs the metrics. This one logs the artifact. The artifact is actual is the actual it saves an image. It saves the plot for you as the image, right? That means the logs of everything that is going on. So it's so when you want to log the model, like save the model as a file. So this is when you use this function. So it also you include signature environments and input examples. So okay. So you can also do this as well using the ML Studio. So this is how you this is an experiment that was created earlier. Then you click the experiment, you'll be able to have access to all these metrics. You can see the metrics that so this is how the thing was created in using the ML sorry using Python SDK. So and you can log any metric you want, right? So sometimes it doesn't automatically log loss. You know, that's what you call all these loss function, cost function, or um, all these parameters when you're working with your machine learning. So these are where you can automatically use your own custom logs that you want. That you don't want the default one offered by the auto login function. Okay, so we've gotten a okay. Let me go back. So I believe you guys have gotten a good overview of how to do this. So all this is going to take is for you to practice all these, practice the AutoML, work with all these, and know when to use. And when you're working with AutoML, you know how to use. There are many options. You can use the auto login function, or you can use the custom function to be tracking your model, like to be tracking the performance, the metrics. So so this makes it possible. So it's ML flow that makes this possible in your Jupyter notebook. Okay, so yeah, let's go to now the how to optimize the process of training a model in the Azure platform. So so now you are through writing the code, right? So you are done. Okay. So now when you are done experimenting using the Jupyter notebook on either your local machine and or using the notebook on Azure platform, right? So you can convert the notebook to a script. Okay, so it makes it converting to a script makes it ideal for you to be able to run make and automate for automation, right? Because when you are running your code in production, it's best to have it as it's best to have it as script because it makes it easy to automate. So you can run it at multiple times you want, and you can easily scale it to multiple environments. So now to make sure that your script is production ready, then when you are done with the automation in notebook and you want to take it to production, then you need to remove all non-essential code. You need to refactor it. So we are going to look at what does mean to refactor. I know some of you are already aware of how to do all this, and you need to test your script in your terminal before you actually put it to platform. So now, so example of a non-essential code. While you are experimenting, you probably be using all these describe. You'll be using after importing a data frame, right? You are using describe, or you are using .ed or .tail or .info. So all these are unnecessary. So you need to remove all these non-essential code from your code. So then you need to refactor your code into functions. That means you need to split your code into functions. So this will make it easier to read and test the functions as well. So this is an example now. So this .ed now, you need to move it away. It's not essential code. So then, so this is a particular aspect of turn it into when you factor your code. So you put a place there now. This is a particular function. No, no, no. Yeah, this is it. So this is an example of for putting your code into a function. So you separate the parts. I know when you are doing it in your notebook, you do all this. You can probably do all this in the same cell on your notebook. But you need to now make sure that you factor your code. Your code is not just you can't just take your script from notebook that's giving you the best model or give you the best performance that you want, model performance. And you don't just use it direct. Just you don't just copy and paste it directly. So you need to make sure that you take away the unnecessary code. You now use functions. So use functions to refactor your code. So you did if so you now say, okay, now for mail, so now you go this one is the aspect that is taking the data, right? And this one is splitting it. This is another function that we read the data, right? So this one is not that not so you can see that everything is into functions. So this makes it very easy because there might be times you want to debug your code. This makes it easy for you to debug and be able to know where there is a error, probably error, maybe there is a your code is giving you some kind of error, so you're able to know, okay, it's probably this side that the error is coming from. So so you can see how everything is neatly split into functions. So this is what it means to refactor your code. So then you need to test your script. So you can in your terminal just run Python, then the script, right? So then you can see the results. So you can just so it's as easy as that. So now how do we now run it as a job? So let's now talk about so we talk about how to prepare your code. So we talk about how to convert your notebook, right? Your digital notebook into scripts. So now, what does it mean to run a script as a job? You can run your scripts as a job by you'll be using some commands. You will need to specify all these parameters in your script, right? So these are the parameters you'll be so this code is one that takes in where your script is located, maybe inside your local machine or sorry on the Azure platform. So it's going to point where it's located. Then the command you're going to specify which file that you want to run. There are multiple files in that folder. You can have the one that is doing the training, right? And you can have the one that is doing the prediction, okay? Or you can have the one that is doing the maybe just one that is doing only the data splitting alone. Okay, so you can specify, okay, this is the one. So this environment, just like I said yesterday, this environment this is to tell you the packages that is needed to run your code because when you're running something as a command, it's using what we call Docker instances, right? So it's using what we call clusters, and all this environment that is running, so it needs to be duplicated. So in case it needs to scale up or scale up the clusters, so this environment will be easily replicatable in other instances. So then you now you need to say the kind of compute you want to use, right? And I believe you know the compute or you have to use because you can use a compute instance or Spark, solid Spark in this instance. No, it doesn't work. So you're in the production stage. Right? The best thing is to use cluster, so like AML cluster, or you can the name can be seen when you reference the material later on. So now you can give this name. Just this you let you identify each of the individual jobs. So at least the experiments, like the can be one experiment and you have many jobs, right? So maybe this one is just to train, another one is to split, another one. So you give so you associate them into one big experiment. So so this is how you configure a a file that you've done in your notebook, right? Using a Python SDK. So this is an example of all these things that I said. This is how you configure the job and submit it. So you inside the script, right? So we can see everything here. So you have a code. So this is the location. This is the command line. So the command is that Python, the trained of Python. Okay, so then is the environment. So this one is what we call curated environment. So you should be able to remember this. Then complete cluster. So we have the AML cluster. So which is the best one for you because you are using you are working in production or likely to work in production when I start running jobs. So now display name that you give it is train model. So this make it so now the experiment it belongs to is train clarification model, right? So how do you now submit this job? So don't forget that you use the or part of this ML clients class. So you uses this particular method, right? Create or update. This is how you submit a job. So you can start run. So now we need to talk about how to use parameters. So there are times that you want to your code, your script to be able to take in parameter, right? That you want to take in maybe input or output or argument, just pass arguments to it. So these are so so now this is an example function now, right? So you see that it is test of all these how to add arguments to it, and so you can say where you want to pass the input and output. Let's continue. So passing arguments. So now this is what example does it mean now that okay, you can say so you can say Python train.py. Then this is how you pass in the data to it, right? So in case that you want to pass in, you want to take an argument. So an argument like maybe you want you to take an input. So these are you designate it here. All these are what you are already used to already. So this is the function that is taking it. So it's going to know that. So now when you put this thing here, so it's going to know, okay, anything starting with this particular phrase, sorry, this particular variable name, right? So then the thing following it is the input that it's going to take. So this is how you add arguments to your code, right? So now you can see it here that if you want to pass a parameter to your script, creating the job in your SDK, so you can see that you can put it here as well. You can see that, okay, now you've done the Python code, right? You've done the notebook. You've created you've converted your notebook to a good script, right? Then you need to take, this is train.py. Train.py, so if you want to train, you need to take in a data set, right? So this is how you pass in a data to it, and this is how you do it. So it's going to now work. So okay, now okay, we look at looked at how to convert a notebook to a script, how to test it on the terminal, how to run it, how to pass parameters to it. So let's go to the next module. So in the next module, on how to optimize the model training process on Azure machine learning. So after learning how to run this JS, the script as a command job, they need to know how to track the training with ML jobs. So when you start running the jobs, so you need to track it, right? You need to be tracking, okay, like you need to be tracking the performance, the model, the versions and everything. So when they talk about how to you can do it, the option is by you can enable auto logging using ML or auto log. So you already seen how to do this earlier. But you can use the cost, you can do it custom, you can use custom, you can do it custom, you can use, like if you want to use a particular matrix that this one is not giving, then you can use the custom option by using this ML log. You can see this underscore here. So maybe you want to log parameters. So you put params or however it is written. So then it does. So now, how did that include an ML flow in your environment? So in the why they are declaring the job earlier, so you can see that there was a place that says the YAML file. This YAML file is the one that talks about the yeah, okay now, okay, yeah. When we look at the environment earlier, we use what we call created environment. So in your this now is what we so we want to do what we call custom environment, right? They want to use a curated environment. So you want to a custom, we want to custom model you customize yourself. So this is how you do a YAML file. So you write all these things there. So these are the dependencies, these are the what is going to pip install. So you can see that among the pip install, you put the Azure ML flow and ML flow to it so that it's going to run all these before. So the job is so when the job is running your code, it's not going to be saying that it's not going to be saying that by the or the yeah, module error or something like that. So this Autolog supports all these libraries. So these are also one of the reasons why I want to use custom logs. So when you are working with a circuit, if the algorithms you are using to train your model is either circuit length TensorFlow and Keras or any of these algorithms. So Autolog supports this guy automatically. You just need to measure in your code. You do mlflow.autolog. So when you want to do it, automatically this means that if the algorithm you want to use is not among this guy, then you automatically need to go in for custom log. Yes. So this is how you. So if you want to log a parameter, then this is how you apply metric artifacts. So this is how you do all these things. So this is how you you have a script already and you want to add ML flow to it, so you can just do it like this to your code, right? So you just mention on your Python and script, your train.py script that you converted from notebook to a script, right? To run in a production or to run as a job. So you just make sure you import ML flow. Since in your environment you've already declared it in the environment that so you've already done it here. So this is for the so you make sure that so you want to be logging parameters, that means the regulation rate. So these are example of parameters you also I believe you guys can yeah, I don't need to all this what we call parameters, data parameters, metrics, and so on and like. So let's now look at metrics and how to evaluate models. So in Machine Learning Studio offers you on the Machine Learning Studios. So the experiment that you are running, that you want as in when you want this job with okay. Oh, let's continue. So when you are running the job, right, it's usually part of an experiment on Azure platform. So when you find out a Spark experiment and you click on details tab on it, so it's going to show you all the log parameters that you've already declared in your code already, right? Doing the script or doing the custom log or also log that the parameters that is showing. So you're able to see all the metrics. Then if there's an artifact that is logged, you see it under images, right? So if there's any model, if you are activate that you should be saving your model, you register it. And so you should be storing it under outputs plus log tab. So how to retrieve metrics when you are working with MLflow in notebooks? All you just need to know is you can do this using a for loop to iterate through the experiment, right? So this is the experiment. So you iterate through it by using this, or you can retrieve it by using the view type. Or so these are one of the ways you can do it using using the Python SDK or while you are working in the notebook, right? So this is how to, if I work for a particular experiment, just say get experiment by name. So you get a particular experiment, you put it here. So and you are searching for, if you look for multiple search. So these are actually, so now you want to get a particular run like a particular one, you want to get the metrics of a specific run. Maybe just run it. Maybe you want to run at a particular time or something. So this just giving you more of a filtering. Like you want to filter, you want to get okay. Maybe you remember that a particular time this thing, the experiment was good or something like that. Then this is how you can do it further. So these are just you writing simple codes to iterate through all this. So this just filtering it at other bytes, then start time. So you're able to see. Yeah, okay. Like, okay, you want to see so by seeing that start time then decreasing, so that means you want to see the last two results, right? So when you say in descending order, the last two, you want to see them, right? So it shows you this is how you do it. So these are just how to get the how to retrieve the metrics. You want to retrieve the metrics in a node, but after you do the conversion, you want to you want to access all these configurations. So next, so yeah, this is how to do it for number of books using combination of parameters. So, okay, I think yes, we are at the end of this guy. Okay, we look at how to do custom logging and also logging. So, okay, so we've looked at how to um, turn your scripts, training scripts in a notebook to make it ready for turn to a job, right? To run it as ML. So, and how to track it. So how to make the necessary modification in your code to track it. So how do you do an hyperparameter tuning? Okay. So there are many things you need to be you need to know. There are some key terms here that you need to know. So now when you talk about hyperparameters, the actual the parameter refers to the parameters are the actual details that will be stored in your model, like the weights and bias. But parameter are the things that are external to the model. That's you. Although machine learning, the whole point of machine learning is that they learn this thing by themselves, right? So the upper parameter is talking about things that how we can influence their learning. Okay, so we can influence their learning through by setting the learning rates. Do you get? So this will be able to, this will now in turn influence the parameters such as the weight, right? Or the so or you can also do the batch size. Batch size is part of what we call parameters or our regulation rates. You get, so these are the ways for you to tune your model so that you can control, okay, how the training goes, right? Because machine learning is something that's the whole point of it. When you say AI, it learns by itself. But if you want to influence its learning, right? So these are what we call hyperparameter. So how do you now perform this hyperparameter tuning as Microsoft Azure platform for your machine learning? So that is what you need to know. So when you are doing the configuration for this, so you can do what we call the SAS page, the parameter value. Uh, okay, so if the data some parameters have what we call what about their search space. That means the space available for them, like the values they can or have, right? So something just like when we say analog and digital. No, analog is infinite, right? While digital is what finite. So this is what I mean by the search space. So when you're talking about discrete parameters, so these are ways you can configure discrete parameters. So for the when you want to train, if you want to configure the discrete parameters to for discrete distributions, right? So these are the options you have. You can see that you see Q uniform, right? Q log uniform, Q normal, Q log normal. So this is going to use so this is going to take in discrete, like it's going to be infinite, it's going to be infinite space, right? So when you're working with discrete parameters, just know that you use these are the ways you can configure the parameters for when you are dealing with discrete. So it all starts with Q uniform, a log uniform, Q normal, Q log normal. Okay, so when you're talking about the parameters that have continuous values, right? So you need to, so of course you can't let it, yeah, when you are doing your parameter tuning, you can't let this thing run for infinite because that will be a waste of time and resources and we won't get anywhere. So now, so when you are dealing with continuous other parameters, so these are the ways you can set their parameters, right? Their distribution, this distribution. So the types are uniform, log uniform. You can see that the difference between it and discrete is just that there is no queue. So just put that, just notice that, right? So how do you now assign a subspace? So now this is an example now for the. So now well, when I said that when you are dealing with running jobs on the Azure platform, you can say something. You can run it as a job or as a sweep. So when you want to do hyperparameter tuning, that's when you say sweep. Okay, that's when you say sweep. So that's why you say command job for sweep. But if it's just a simple something, just a job. So what if it is a pipeline where you want to multiple, so you still get there, so you still use pipeline. So okay. So now this this is how to, for instance, now the um so now this is an example case where the SaaS space. So now they want to in this case where you, let's say you want to influence the batch you want to modify the batch size for the parameter and it can only have 16, 32, 64. And the learning rate can have any value for a normal decision with a means of this and this. Because you know that learning rate can be learning rate can be it can be infinite, right? You can take any, it can be infinite. So this is how you use normal. You can say that you use normal. And here you use choice. Batch size is finite. Batch size is something that can go from it doesn't pass it's a finite number. You guys know what we call batch size. That is the number of amount of training that the training takes per time, right? So that is what we call batch size. So you can see that you use a choice when you are dealing with discrete parameter. You can see just like choice or something like that. So now this is normal. So so now the while also doing your parameter, that's what we call sampling. Your your model, the parameter cannot sample all, you cannot sample all available combination, right? So if so, this how you can perform the sampling. These are the available sampling methods in Azure for you to when you are doing your parameters tuning. So if there is grid sampling, this one tries all possible combination. Just that they say that you want it to try all possible combination. That's when you use grid. But when you want to do when you want to do it, want to do random sampling, that means probably you are using this random is best when you are using what we call like your data set are infinite. Sorry, they are not discrete, right? So grid sampling. So Bayesian sampling is just so these are what they mean. So ball is a type of random sampling that has a seed to sample it has done then to make it reproductive. So some random sampling it chooses the in the space, it chooses any place random, it chooses any values randomly. And grid tries all of them. Bayesian sampling chooses the value based on the previous results. So depending on your use case. So let's say you want to the parameters you are dealing with is of discrete values. Okay, grid is the best because it tries all possible combinations. So it's best for you to use for discrete data, right? So that this is how you apply it to it. So you say that after doing it here, after seeing your after seeing your with this thing is kind of okay. Okay. After defining the SAS space, right? Yeah, maybe you're using kingdom map for the distribution or saying your option. So so now this is how you add it to it that okay, you add another line of code. So this is where you now add the grid that you want to use the grid sample. This is how you notice that okay, your code, this is how you use grid sampling in your code. And it's best when you are dealing with discrete. So it's going to try everything. You can see here that we are using what discrete here. You can see that there is choice that is not normal. Okay. So now in random sampling, now this one is going to just take samples of so that means when you are dealing with when you are dealing with infinite parameters, right? You can see that the learning rate here is what is normal. You said normal, right? So now this sampling algorithm so it said this to randomly. So it's going to just randomly try them. Okay. So it won't be able to it won't be able it won't just go through all of this. Just go to take them at random, just to take a sample of them, not everything. So at random then, so depending on so all this we all know that machine learning is based on probability. So random some randomization increase the probability. So now the snowball is just an aspect of random that has seed into it. So you that you just do it. So after is a random sampling, you just that seed something and so but so this add seed to add the seed root to it. So now Bayesian sampling, this is the one that where it added it added some based on previous performance of the parameters, right? Maybe the performance is performing well, so it's now going to add new. It's going to choose them based on the previous performance. So this is when you are using Bayesian sampling. So you all should be aware of all these ways of other parameters. So these are just how to you are just showing you how to apply this on all on the Azure platform. So now you can't let your Apple parameters to run forever, right? On the normal, it depends on you. you can decide to just train your model and get the result, or you want to be you want the model to tune by itself. Like you want to give it good parameters to start your training, right? So that is when these are the cases where you use upper parameters, then this thing can't keep on running forever. Okay, so you need to compare what you call early termination. So early termination policy, there are types of ways you can implement this in your code. So you can use what you call evaluation interval or delay evaluation. So these are just the parameters you can pass in. So the examination policies that you have available in Azure that you can use it bandit policy. This one is going to use a Slack backup. Okay, so that means when you use a bandit policy option, it's going to say that okay, if they perform in a particular range. Okay, so now when you say median stopping, so this is when the median of the averages of the metric, like the metric that you are using to judge like the metric you use, maybe you're using AUC, you're using or the recall or the precision or whichever or mean square, this mean root square error for your regression model. So it's going to make sure that it stops the performance that is being that it stops within a median in the average of the primary metric that you are using. So now truncation selection, this one uses percentage. Okay, like the percentage of the lowest performing trials. So the model that perform better than the lowest performing one, then it's going to take it, then it's going to stop. So these are ways for it to stop early. So the application doesn't run forever because you can't waste time on it. So this is how you apply it in your code. So you in your script, then you put it like this. So when you put 0.2, when you say that and say slack amount of with a delay of 5 trials, and so that means that with a slack amount of 0.2 means 2%, right? No, 20%. So this is how you apply it to your code. So you say bandit policy, then you do all this. So this is how you apply this. So you can see that it stops at slack amount of 20%. It doesn't go beyond this 20%. This is a top performing model. So when the performance keep getting down, so when it gets 20% of the top performing one, then it stops. Then the alpha parameter is finished. So now when we talk about median, so median to just use the average. Like okay, use the average. Like okay, um, use the average or the worst performing one. So this is how it does it. And truncation selection. So this is where you use a percentage of for the lowest performing trials. So you can see how the 20%, all these are the set truncation. So here how you implement in your code. So I think it's done not all. Okay, so how to create a script for upper parameters tuning. Okay. So this is an example using uh using the so all everything you said so far. So you are implementing into a script, right? So you say that you have your training your scripts. So this is how you apply everything in written. So you can see that this is where you put the um let me see, okay. So okay, no, this is not refactored. So this just shows you how to create for a performance. Okay, for when you are doing a performance, how to you know that the whole point of doing the parameter is not for use for production. It's just for you to find the best parameters, right? You don't want to give you the best parameter that is performing well. That's what for a particular algorithm that you choose. That's the whole point of our parameter. It's going to tell you the learning rate that you should use, the learning rate at which it is performing the best, the regularization rate that you should use on the accuracy metrics. Okay, so this is how you do it. Then so this is a simple script for the regularization. So you can see that so you apply the input arguments so that you can pass argument to it and regularization, then send it, then if you put it, then you'll be able to apply it. your relation to your work, to your to the job, right? And it's a sweep. So whenever you're running a job as a sweep, also that so yeah, when you want to do a upper parameters tuning, it's you are going to be doing what we call a sweep job. Okay, so now, how do you do all this? So to prepare the script job, you first of all create a base command job, right? Yeah, you first create the first command job. So this is the first command job, right? So you can see this base command job. Then you now define the parameters by the since this is the script, right? So this is the base command. You can see that in it, then the parameters you are passing in the regularization. So it's going to be taking this thing as input, right? So since anything that you are saying that input is taking something that you be passing on the output, sorry, it's going to be taking in it to apply. So then you can now override the input parameter with your SAS space. So like since you use 0.1 here, you can see use a distribution, right? Just I want to talk about the distribution that is available. Maybe you want a discrete space distribution or you want an infinite space distribution. So we're using a discrete space distribution. Sorry, yeah, a discrete space distribution here. Yeah, you can see here. So now then you now finally call the sweep command. So this is how you do this. So now see the command job dot sweep. Then you now put in the clusters for it. The algorithm, algorithm sampling algorithm, which is great. It is great because we're having a discrete spacing, so of course it's going to be great, and it's a job, right? So because you want to be to scale up and down, and also you need a cluster for the compute. Then your primary accuracy is your primary metric. That's what you are using to judge by. If you want, you can use AUC, EUC, or if this is you can use AUC, recall, precision, all depends on you as a machine. So I believe you guys know all this. So if you don't know, please just know them and read further on them. All these things are important. So yes, so now this is now the yes. So after you then to attach it to an experiment. So you give it an experiment, then you set the limits, right? So you set the maximum number. So wait, the what do you say? The okay. Okay, for the early termination, you can use the termination policy, but here it was not used. They just use the timeout. Yeah, you have to limit the sweep. It doesn't run forever. So now then after you done, then you can start running it. You can start monitoring it. You can monitor the process, the performance, right? You can monitor it in your machine learning studio. By clicking on the experiment, then you see everything there. Okay, okay. Don't forget that the key thing is that how to run a command, how to create a job sweep, the particular commands you'll be using. You can see that it has your sweep there, then you want to submit and create dots of the updates. Just note all those methods down because they are quite important. So so now we are done with how to perform mapper parameters tuning on the Azure platform, right? So now, okay, so yeah, you've gotten over how to turn your particular notebook script that's into a good script. Okay, so allow to track to be tracking the training in your notebook. So you're going to want that how to perform parameter tuning, all the things that you need to note. You need to know that the SAS space, right? That discrete and infinite. So it's all I say infinite is continuous. So you need to know where to use one. So all depends on you. So and depending on whatever you choose the corresponding template method for it. And you configure elimination, early termination. Yeah, anytime so it stops when you get the best one. So you don't just keep the parameter tuning just keep on running forever. So then we now show you how to now do the convert it to a sweep job. Because when you are doing an upper parameter task, right, it's normally a sweep job on the Azure machine learning platform. So now let's now go to uh, pipelines. So Well, how do you create pipelines on the? So what is pipeline? So all this let's say that you are running a simple job, right? So all these things can be put together as a pipeline, okay? Because it makes it easier for you to be able to automate it by using what we call cron job. So cron job is for you guys that don't know, cron job is like using is a way you automate something, like something to schedule something to run in Linux. So we call it a cron job so that the particular time is in run. So you want to implement all these kind of process of machine learning, these as a machine learning or ML ops, the person is that you need to implement all this thing as a pipeline job, right? So when you have multiple of jobs, the best is to, and you want it to be running at a particular period, you want to automate it to be triggered at a particular time, so you turn it to a pipeline. So it makes it easy for you to manage and to run and reuse your code. So now let's see how we can create components. So now, components are what allows you to use your scripts. So you can share it in the same workspace and across the same workspace, giving the permission to anybody that have access to the workspace. So the reason why you use a component is that when you want to build a pipeline, you have to use a component. If you want to share your ready-to-go code, use a component. So is this thing signed in? Okay. All these are here on the Azure. All these are here on the Azure platform. Let me see, let's load. Okay, it's something we need on it. Okay, so this is how you create components on the Azure machine learning platform. Okay, finally it works. Okay, it's still loading. This is how the machine learning studio looks like. The ml.azure.com. You cannot go there, but it won't give you all this. It won't be giving you this authoring section, this data section, and the manage section, unless you have you created have an Azure subscription already on portal.azure.com and you created a workspace. But it's that workspace that you will use here now. So that's why you can be able to access all this. So when you access this site now, it won't give you all these things. It won't give you all these icons, all these menus and everything. So it will be different for quite different because you log in to a workspace using your subscription and okay, and start working. So when you talk about components, is this in login? So you can see this is a component, right? So you can upload the source files for the components from your local machine as either a zip file or folder, depending on you. You can say that you can upload it. So there are three things you need to know before you create a component. The metadata. The metadata is component name version. So it has a component has the metadata, which is the name and version, the interface, which is the parameter like data, the things that we entering it, right? So the interface refers to the input parameters and the output. The example of input is the data set that you are using for training or the parameters that you are passing in for other parameters tuning. So the output is the things like metrics, like it's going to give you an output, right? Depending on how the model performs and the training goes. So it's going to give you an output. Then artifact is when it saves your model version, so it's saving as an artifact. So then you command code and your environment. So these are what you specify how to run your code. So now to create a component, you know what we call a script and YAML file. Okay, you can put this inside the zip which you are going to be uploading here. Okay, you are putting inside your zip file which you are going to be uploading here. So the YAML file is what will contain your metadata, right? So we're going to be seeing how it's going to be written. So the script is it contain the workflow you want to execute. So you see how it works. So now this is an example of a Python script, right? So this is a prep.py. So it prepares the data by removing missing values for normalizing. So you want to be running this as a pipeline, right? So this is a component now. So these are the libraries needed for the. So this is the script. So now you can see that still you had two arguments, right? So the one for the input data, the data set that you're working on, then the output data. That means after it has so this particular code you can see from there is just to prepare the data. Or instead of you using but not everyone will go to prepare using AutoML because AutoML it abstracts a lot of things away, and most of we ML develop machine learning engineers, we like to get down to the custom level and have are able to see things and to gain more control. So AutoML doesn't really give you much control; it just does everything for you. So it's isn't good in all cases, and in some cases it's good if we just want to do something quickly and you are not really interested in the nitty-gritty of it. So now, so you this is a sample prep.py. So yeah, you can see that it has the argument that is taking in the data and the output. So and it reads the data, it does all these things and it analyzes it. Okay, these are what automatically does do for you. If you are the type who prefer low code, let me say no code. Yeah, you prefer low code, right? You prefer low code, you use AutoML. So this is the for people who likes using code. This is how you create a component and run it. So now you said that to create a component, you need what we call a script that will execute the workflow. So this is it now. And then you need what we call the YAML file. So this is the YAML file, right? So you can see that you have this the schema, you just this name of the prep data name of this script. So you just add the display that you've shown. So now you now get rid that type is command, right? So input data. So URI, you are using a URI file. Okay, since it's a single file, so nobody is a URI file. So the output reward is a single, it's also a single URI file, right? The output can be since you are trying to prepare a data, it's going to take in one data, right? And it's going to give you the data that is, since the data is just the raw data, so you want to clean it, you want to you want to make it you want to process and make it ideal for your machine learning, maybe scale it, normalize it. So then it should take in the one file. That's why we're using URI. The type is URI file. Then it's part of a single URI file, right? So now you also have to declare the environment. From what you're having here, now you can see that the environment is a what? Is a created one, right? So it's not a custom environment. So now the command, then under the command, so all these things, this is how you declare the YAML file. So you need to put all these things there. So you see all these the command is that this is what you should do. So you take in inputs. So these are you want. So these are dollar sign is one taking the variables in. So anything you pass into it, you're going to take it as data. And it's going to pass this place as your where it's going to store the data. So now let's look at how so this is okay. So now how do you now load the code? How do you load the Python the components, right? So this is how you write it in your this is how you write it. So you're using the SDK. So you import these guys, then you say load components. So these are how to reference the prep YAML, and so you need to make sure that all this YAML file is inside this guy. So you need to add it inside this script so that it's going to use it while running, right? So so now so how do you register a component? So you can register a component in the by using this you register a component by using an ML client as components, then create or update, then it creates the particular uh paper data document, right? So you register this component, then when you run it, then when you run it in your Python SDK, so you have So this thing will run, and you get a working component. So now you have a component now running, right? So how do you now create a pipeline? So so what is a pipeline is simply just a combination of machine learning tasks, right? That they are all trying to achieve the same thing, right? Can I show you a sample one, an example here? Okay, is there one I can? So when you run a sample, you know what's going on. Okay, okay. So, okay, maybe we see how this works later on. So so when you create a pipeline, so is a basically what the pipeline is a combination of jobs. Okay, so the jobs are the yeah, sorry, I said jobs, components. So and then you see how to create a simple component. So that one component was all that one is doing is what it's for the preparing the data. Okay, so that everything is going to work sequentially. So that when you run this thing, when you trigger it using your current job, so it's going to first start with um what do you call it? The preparing aspect, the data processing, right? That one's going to run. So this pipeline is when you want to create when you want to automate your process for ML operation. This is what you do. It starts with the data, getting the data and cleaning the data. Then after training the data, the data is good. Then it goes on to training the data. Then sorry, after training the data, then you use that data that is the output from the trainers, from the prepared data, let me call it prepared data that has been cleaned and the process. So it takes it to so into the training trading file components. Then it all goes on until you have what you call an output. Then you can run it. So okay, good. This was what I was trying to do on the platform to show you how it all this is how it will look like, almost similar to this on the platform when you have a pipeline running. Okay. So let's start. So how do you build the pipeline? So everything, all the pipeline operation is going to be defined in what we call a YAML file, right? It's going to contain the name, output, settings, input. So this is a sample. So now, so you use that. You can use the YAML file or use this function at pipeline. Okay, at pipeline function to create the YAML file. Okay, so this is it now. So this is a sample pipeline now. There is it prepares data, then what it does, then it trains it. So you can see from here that pipeline function. So you define it inside a code, a script. So now, so you can see that you just this is how you declare you start importing the libraries. Okay, so then the data, the prepared data. So now, since you've seen how to we've seen previously just if I should go back now, if I should press back, when we were all those things we were doing, how to create a component, right? So this is a simple component that you've created already. After creating it, after loading the YAML file and the script, right? Inside the maybe it's inside the zip and you put it created the component. So now this, so you now be able to access it that okay. So prep data is the load component prep, right? So this is it. Then the input data is pipeline job inputs. So this is the name of the what? Sorry, this is the name of the okay. So now this is the name of the sorry, the component that is the one doing the prep data, and also now this is the component that is doing the training data, right? So this is how so this is how you define it in the code, right? So then you can see that the input into this training date is input sorry. this training data is taking prep data. You can see that it's the output of this guy is what's coming in inside there. Hope you can see that, right? So the output of what is coming here is what is coming in as the input here. Prep data dot output data. So what is coming out here is what's going in here. Okay. So that's the service. So now it's going to return all these things for you. Then it's going to return so this is the this first one, the transform data, right? The clean data, whatever, this is going to give result. And this one is the trained model, right? So output dot model dot output. So this one is using this. Then this is this is going to return this one first. Then what it returns there, we now come here. You can see that they are basically the same. So it takes in it, then it uses it to train the model. Then it saves it for you. The model output. Then you have the model. So you can see that everything is automated using pipeline. It's gives like an architecture, like a structure to architect everything to, so that you can be able to perform automation and run these things and do this automatically, right? So now if you want to pass the register data set um as a pipeline job input, you can use this format. Now, when the data, when I said that, as well is when the data is on Azure machine learning work, so that means data is already stored. If your data was stored on a data set, right? Azure ML data set. So you can, okay, okay. So now you can see that it's using the Azure ML protocol, right? So that's why you're able to access it. So if it was on block storage, you'll be seeing, I think HTTPS or ASBFS or WSB, I don't know, but I believe you guys have noted it down from our previous classes. So it's right to the first data that you put in the Azure Miner. So it's going to know that, okay. So now this is how you create a function that will access the data that you register data in your data state, the one you put on Azure. So now, so this is what happens from this simple code that we have here. Where is the code? Yeah, from this simple code that we have, this is what is happening. So this is what is happening, right? This everything is going step by step, step by step, step by step. So you can come and read it. Just I've explained it to you. So this is how it's going to run now. So the pipeline function name. So one, it's declared itself. So this is everything. This is the namespace of the function, right? So now it's going to take an input. So you first run we have where is it? You can see in the code, you have a pipeline job input, right? So now this is the pipeline, this is the component, right? So it takes in data, then it's going to it's going to produce what we call prep data, right? Then it's going to output the data. So that data is what is going to pass into the training data. You can see is all here. Prep data, train data. You can see this is for the prep data and train model. Yeah, so this is the prep data. Sorry. This is the prep data code that you read. So it's going to take in the input from this one, then give you the output. So this train model is going to take in the output from this one, then give you a model output. You can also see something, you can also see that the data, why it's also going, is also going somewhere, right? So it's being stored as a pipeline because you have to, you also store it like, okay, where is it in the code? So this is it that pipeline job. So you are saying you should return it for you, right? If you don't put this one in, so you will not return it for you. But just give it the as model in. So it's returning it for you, right? Okay. So and then that's why it's now returning it for you. So you can just on your machine learning workspace, we'll get in there later on. So when you click on this guy, you have to access. So after your pipeline has finished, so you can go to the particular tab on the pipeline, then you can click it. You will see the results. When you come in, you click it, you will see the model, right? So you'll be able to look at the model further and say, okay, look at the performance, everything. And okay, so this is how it works, right? This is how a pipeline is. This is a simple pipeline. So now so a YAML file, the output YAML file, which includes the configuration and the so this is a sample of the YAML file, right? What we did there was, where is it? So when you use the when you use what am I saying? When you use the pipeline function, right? So this is the YAML file. You can see this is the YAML file that is gracefully. So it puts all the configuration that you did in the YAML file. So you can save this, right? You can use it to perform to run another you can use it to easily recreate another pipeline somewhere else want to share your code, right? So it makes you can easily reshare this code using the YAML, right? So you can see everything it from the function, the code you write here, you can see that you create a YAML file. You can see it from here. So you can either go to the root of creating this YAML file yourself before, so you now use it to run the pipeline, or you can go to this. If this one is more, yeah, it's better for you to do. So you can go and use this as pipeline function, create everything. But after it has finished, it's going to also create you the YAML file of it. So if you have the YAML file already, then you can start the pipeline. So now let's see how to run. So you run a pipeline job in sorry, you when you finish creating the pipeline, so it's going to run. So just like I said, the pipeline is defined in the YAML file, right? So you can create it using the pipeline function, or you can edit this way. And then so from that function, you can also edit configuration. You still want you want it to act a certain way, you can edit it, a YAML file, then you use it to create another pipeline job. So this is how you okay. So this is a sample code for how to change the output of the YAML of the YAML file, right? Sorry, of the pipeline of the output of the pipeline. So for the pipeline job, I want to change it. So this is it. So then you can, of course, and defaults, just like I said that when you're running pipeline jobs, we went over this yesterday. There are some compute options you use in a particular scenario. So by default, it uses AML cluster. By default, if you want to use AP as that is the Azure Kubernetes service. If you don't want to use it, then you need to come and change this, convert it that okay, you wanted to use something else apart from AML. So then the one by default, everything is stored in block store. So yeah, block storage. Okay, the default storage that it stores in block storage, so you can change where you want to store. If you want it to be stored in Azure file share or somewhere, so you can go and declare it then. So this is the name of the data store, right? So okay, so then you can now print the audit, then you can now see the results. So actually, this is how you run the pipeline job. So you create this. So this is how you declare it to run the job, to submit it for running, right? So you say ML client on jobs or create or update, right? Then you pass in the pipeline job, the experiment name that is. So you pass in the name. So yeah, this is how it looks like. Yes, this is good. This is how it look like. So we are going to do something similar on the file where you'll be showing how to do all this run a simple project from through this route, because the best way is to be able to do this thing in the pipeline, right? To be able to do this end to end, then you are going to deploy it, then deploy our model for the for consumption by the consumer, right? So you can see that all these things once you are not going to design all this, but you are going to due to the virtue of your YAML file, it's going to do all these things for you, right? So you are just going to be writing the code, and it's going to be doing all these things for you. You can see how everything goes, like everything goes. So yeah, so when you click on this, you can see that you can see the output, right? The output is it gives you a train model. This is the model, the clean data, then you have the clean data. So this is, so you can come here and access it and click on it, right? So now if there is any issue, this going to this tab will on the pipeline job. So we give you're able to see where there might be issue. You can see that it takes here. takes it. So there's no issue in any way. It runs correctly. So if there's any issue, you can come here and click it. It's going to give you some errors. So you can use from that errors to try and debug your code and see how you can fix it. So now, how do you now schedule a pipeline job? I know that the whole point of a pipeline job is for it to be scheduled, right? To be triggered. Um, so this is how it is run. So the various ways if you want to schedule the pipeline job, you use what we call uh, job schedule. So um, okay, sorry for that. So um okay, so how do you schedule it? So you use the job schedule class, then you use this time you use the time-based schedule. You're using the recurrence trigger class with this formula using the frequency or the interval, right? So let me explain what it does, right? So when you use a recurrence trigger, it takes in frequency and interval. So the frequency can be either month, or the interval is like the number. The interval talks about the number of time it should run, right? So the frequency is that when should it run? Like, okay, for instance, now this frequency minutes means that minutes, the interval, is giving you the units, right? This frequency is telling the units. Like, is it an hour? So the interval you should run, for how long you should run for, the interval is 1 minute. So this is it. So now when you want to let your work to so let me see, schedule a pipeline now. So you can easily schedule a pipeline using the apartment SDK. This is how you do it. So you can see that the job schedule class, then inside you see the trigger, the current trigger, then you assign it and the current the yeah the corresponding parameters. Then the job schedule, so you give it the schedule. So okay, so then there you have this example of see, this is a scheduled job now. It run every 1 minute, right? It run 1 minute, another minute, another minute, another minute. So this you can see. So you can easily also be able to look at your work. So if you want to delete the schedule, these are just, you just know that you use them in the schedules dot begin disable, first disable it, then delete. So you can't just delete, for first you need to disable before you delete. So these are ways you can do it. Okay, so let me see, is there anything next? So yes, so I believe we are at the end of the this, let me see, I think we are, yes, we are able to look at how to um to optimize to run experiments, right? We look at how to experiment on the Azure machine learning by using the notebook and track it. We're using the ML flow, and how to where is it? So how to find the best calculation model using AutoML, right? Then you know how to optimize our machine learning process, right? You can see that when you use pipeline, everything is automated, and you don't need to be starting it yourself. Everything is automatic. So this makes it good for good ML operation and make your code ready for production. Like it will decrease time from development to production. You make your model available almost instantly for consumption by the user. So yes, so we'll be able to look at all these, how to perform parameter tuning and run pipeline. So yes, so I believe I'm through with the module. So over to you, Tejimola.
Okay, thank you very much, Emmanuel. I'm very sure that uh, we have learned so much, and then we can now build uh, on an AI model using Azure. So please, I want us to celebrate and thank Emmanuel for the job well delivered. Please, with your favorite emoji, I want you to celebrate Emmanuel for that, for the good job that he has done. So if you have any question, you can always ask in our Telegram group. or if you have any question at all, kindly do that on the Telegram group. Okay, so don't forget that today there's still a section on trustworthy AI that's coming up. So do it to register and join. The link to join will be shared on our Telegram group too, so that you can just pick it up from there. Yeah, the link to join will be on. So watch out on the Telegram group for the link to join this section. Okay, so in the absence of any other information, tomorrow is another day. So let's be punctual. And if you know anyone who's supposed to be on this call that's not on the call today, please do share the recording. The recording will be available immediately on our YouTube page. Ask the person to watch, and then you can also it's also encourage the person to come very early tomorrow so that such a person will not miss a lot. So thank you very much. For this program, there's going to be an hackathon. So I want you to watch out for it. There's going to be an hackathon for ML and then for all the tracks that we are running for this for the free in every city. So there's going to be an hackathon. So watch out for post and then definitely you get the updates from our Telegram group. So thank you everyone for joining and do enjoy the rest of your day. Bye bye.